process then is for the teacher, myself, to walk around the room and see what kids are drawing. Okay, see what they're coming up with, how they're drawing the path, how they're drawing the pattern, what they're coming up with. That's all the direction that they come up with. And what I end up doing is then synthesizing what some of those pieces are, or what some of those ideas are. We'll get some students that will say, they'll suggest that the ball will move in a pattern when the tube is lifted here with the X. Some suggest that the ball will continue in the same circular pattern and then roll off the table. Others will suggest that the ball will, when it's released, may head off this way. Others are going to suggest the ball will, when released, you're going to see that pattern. You're going to see students that will suggest this kind of thing happening. I've seen students suggest this happens, that it just spins off. I've seen students suggest that the ball will continue in that direction like that. Okay? Because these two are the same. I should really say what this one would maybe be doing is it could come off at a different angle. Okay? That kind of thing. So, walking around the room, then I'm actually collecting what I'm seeing different students present. And I'd label these. I'd come up to the board and I would label. So here's option A, here's option B, here's option C, D, E, and F. Now I may not see all of these, or they may not be exactly what every student's doing, but I'm trying to do a representation or characterization of generally what the class is coming up with. Okay, so the predictions have been made. This is what they think is going to happen. Then I ask the students to argue or come up with explanations, put themselves, so what would have to happen? They have to explain each of the diagrams. They don't have to necessarily explain their own, but they can put them, they have to come up with an explanation for each of these diagrams. So they would argue for why the ball, so here you get the concept of, they've heard that this concept called inertia, that an object in motion stays in motion, and because this motion was circular, the ball tends to keep going in a circular pattern. Right? They may also use that same argument for this kind of a pattern here. Okay? They'll have the same argument, then they say, okay, but it's going to go, I've heard objects move in a straight line because the wall of the tube is holding the ball together. Once you remove that wall, we know that the ball is pushing against the outside, so it tends to push off like this. Okay? Or a variation of that would be D. Others would suggest that it's going to come this way. One other thing that you tend to see, I'll just call this one a variation on C. Some will suggest that the ball will roll out and it'll curl slightly to the outside or to one edge, or it'll tend to curl to the other, to the outside. Because some of them will recognize that there's a spin on the ball that's actually spinning on its own axis, and it tends to spin off one way or the other. So they'll make that prediction as well, so we'll call that G. Anyway, so as a group, they've tried to talk their way through how each of these could be explained, and then the students get the opportunity to write down their own explanation, what they think their explanation is going to be, and that would be again in the E section here. Okay, so that's the explains part. So they make their prediction, they have the discussion about what the different predictions are, and then they're allowed to convince each other, just like scientists do, that their way is the right way, and they're allowed to change their mind with what they think is actually going to happen here. Okay? Before we actually do the experiment, I ask them all to vote. So we try to make it a silent vote as much as we can. So kids put their heads down on the desk and they vote which one of these and which explanation they think will actually happen. Okay? And your job as a teacher is to record that vote. So you may have 3 students voting for A, no one voting for E, some voting for, okay, and so on.